Good afternoon, and welcome to the second week of the System Administration course in the Cybersecurity program at WazU. I'm Lee McWhorter again, your instructor. Last week, I'll be honest, I can't remember exactly where we got. I think we got through all the operating system stuff, but hadn't really dug too deep into lesson 5 of the shell scripting, and I don't remember showing any examples last week, so I think that's where we're going to start. And if that's a bit of a repeat, sorry. I've slept since then and forgotten. But I believe that's about where I've gotten. I've got a note here, maybe show some other examples. So I think I didn't make it quite that far. So we have a little bit of 5 to cover, and it's an important one. It's probably one of the harder ones if you've never done any kind of programming before. I don't mean to scare you, but shell scripting is programming. So we'll talk about that. I think I talked about just the basics, but we'll go from there. And then we're going to talk about lesson 6, vulnerability and pen testing. We're going to talk about secure protocols, an important concept. We're going to talk about secure network and system design, as well as secure deployment in the sense of development and deploying applications and systems. And then lastly, we're going to talk, and if we don't get to it because of picking up a little bit more, or maybe possibly doubling up a little more on the PowerShell and stuff, then so be it. But nonetheless, the last lesson is on the implications of embedded systems and the Internet of Things, which is, if it comes to it, a fairly easy one probably to read through for the most part on your own if you need to. So we covered last week an introduction to system admin and talked about how this is a system admin course for security folks. So we get a bigger picture. It's not meant to turn you into a system administrator per se, but at least expose you to stuff that you, even with some networking experience and previous computer experience, you may not have been exposed to the sort of breadth and depth of this field. And then we spent some time in lesson 2 talking about cloud and virtualization and various tools like Packet Tracer and other tools that we use to simulate and emulate networks, as you already saw, of course, in network foundations, and you're going to see even more as we dive into more GNS-N3 stuff in network defense next week. And so we talked about those tools, and then we also spent some time in lesson 3 talking about all the different types of network components, from servers and systems and switches and all the things that are part of the actual network itself, as well as security related type components like firewalls and intrusion detection. And those are all covered in the book, and of course we're going to play with them more as we keep going on. And then lesson 4 was all about the operating systems. In summary, if you remember, there are basically 3 major families of operating systems. I'll get my fingers into the camera, not that it matters, I guess, but sorry. We have the Windows family of all the Windows operating systems, Windows 7, Windows 10, Windows Server, Windows Mobile, Embedded, etc. We have the Macintosh family, which can make a base claim to actually being in the last family, but because it's so uniquely different and it has its own complete family of Mac OS and iOS and Watch OS and TV OS and all the different OSs that are part of the Apple family. And then, of course, the hyphen or asterisk Nix or Linux Unix world of operating systems, the Unix systems. There are, of course, some true Unix systems out there. And then, of course, there are the Unix-like systems or the Linux-like systems, other clones of Unix that are out there. And it's important to know them because you're going to face them all. And it's surprising how they're all have found their own niches. Windows, of course, is still the biggest install on most sort of typical desktops, a pretty good chunk of the home market and a dominant chunk of the business market. But you will find Mac desktops obviously at home in a bigger chunk, and it's been growing some in the recent years, as well as in certain niches in the corporate environment. And then, of course, while we don't really see many people, there are a few geeks and professionals and folks that use engineers and whatever that use Unix or Linux systems as their main workstation. We see them as servers just pretty much seemingly taking over the world. The vast majority of the virtual machines running in the cloud are Linux, not Windows, not Mac, not anything else, just Linux and different flavors thereof. But of course, even beyond the growth of that segment in the server space, the Android is a Linux-based operating system. And so you really have to be aware of that family. And so then one of the reasons that we then, after sort of setting all those basics, we take some time to talk about shell scripting is because it is really a powerful system administration tool. and it actually fits in here, but also it's something that you need to be aware of as a security professional. You will need to learn some programming. We're going to teach you a full language, Python, later in the program. And so now is as good a time as any. And so if this is somewhat repeat, I apologize for that. But one of the things we do in that lesson is we just be honest, like I am in this video. Shell scripting is programming. We can call it shell scripting to make it sound like it's something different and it's easier. The reality is I don't think programming is difficult, so maybe I'm biased, but I mean, it is easier than, say, programming in some higher level language that's more complex, object-oriented, and all that stuff, which you'll learn more about later. Don't worry about it if you don't know, but it's a good way to cut your teeth. And it comes down to, basically, with shell scripting, we can automate tasks. And what shell scripting lets us do is basically, for all practical purposes, I'll sum it up to writing a text file that is a whole bunch of commands that, for the most part, if not completely, you could have typed every one of them at the command line, and you could have gotten the same result as running that script. But the difference is that you can write the script in such a way that it's a little more open-ended, and that's what we really kind of show you in this lesson. You can easily write a script that says, copy files from here to there. Okay, I want to copy all PDFs from here to there. And if you have to do that every week, you have to take some public shared drive on your network, and you need to copy all the PDFs people have thrown in there and archive them off to this other media and move them off every week. And you have to do that. You could just sit down and do it. If you're Windows, you could do it drag and drop with the File Explorer. You could do it at the command line and just type the commands, copy or CP or whatever, and the full paths and all that. But if you're going to have to do that every week, wouldn't it be easier just to be able to double click a script that runs off and does it? Well, what if you have to do, I got to get the PDFs from the sales public share and put them in the archive. I got to get the backups of the source repo and put them over here. And you have a number of tasks you do every week or you do every so often. Well, then once again, these are all things you could type at the command line or possibly do drag and drop depending on your interface. But that usually takes longer and if you automate it. So you could write a script that would do all of those commands for you, and you just run the script and you go make sure everything happened right and you test it, and then you can just run that script. And so it takes a little longer up front to invest in it, in a sense, and write the code or write those commands out and test it and make sure it's all working right. But this allows you to then automate that task so that, you know, if you're out of town for that week, you're not the guy or the girl who's the only person who knows those 6 commands that gets that weekly task done, and they don't want to ever let you leave the office. You can just say, hey, Billy or whoever takes over for me, run this script on Friday, and everything will take care of it. And so, but then in addition, since if you go beyond, if you really do think, at least the beginnings, don't scare yourself. The beginnings of programming, when you think about shell scripting and begin to think like a programmer, you can add much more power to these scripts. So you can have scripts, and like in the lesson, we take you through some very simple scripts that say copy files from one place, exactly like I'm talking about here. But then we actually have you add functionality so that instead of it being kind of hard-coded and to only take in, say, PDFs, we can instead ask the user input, like most programs do, right? They may pop up, do you want to install this? Or, you know, even if they don't ask you directly, in a sense, as soon as you launch Microsoft Word, it's basically almost in many versions of even auto-open the sort of new document or open dialog box. And so, like, what do you want to do? You want to start a new document, a blank document? It's waiting for you to say file open or file new and do something. And so computers are waiting for input, and then they do what we want them to do, right? So why not write a simple script, even if it's fairly simple, that can do that? Instead of having to write 7 scripts, one that backs up the PDFs here and one that backs up the Excel spreadsheets from the accounting department, I can write a script that I can basically ask some questions first. So what type of files do you want me to migrate? Where do you want me to put them? Where do you want me to get them from? And now this one script, because of those simple variables, which is an important concept, but basically in programming, variables are just a name for something we're going to use. So we can have like the file type as a variable. We can have the copy, you know, the source path and the destination path as variables. And basically by doing that, we can write a script that can now be general purpose for us. We can just launch it. We know this thing will take a certain type of file because it's going to ask us. And it will ask us where, and then it'll put it where, you know, and so we can write scripts. And I'm going to tell you that while it's not a huge part of passing the Security Plus exam, that the next steps up the chain, either way you go, there's two of them now. Well, right now there's only one. Truly, at this moment I make this recording, there's only the cybersecurity analyst intermediate level CompTIA test. But as of the end of July, there will be another intermediate called the Pen Test Plus test. And I actually just took the beta exam, the beta test of the test. I'm a beta tester of a test, right? So I helped them test the Pen Test Plus test this Monday, and was pleasantly surprised to see that it had a fair amount of programming related questions, including one of the scenario based questions where you had to basically kind of at least have a high level of understanding of basic shell scripting. PowerShell and Bash are on that test, as well as Python and a little bit of Ruby. So that's another language to put in your mind, and we may make part of any extension of this program beyond the current track. And of course, it's something that you could pick up. It's another open source language and a popular language, especially for web development. So some of you may already know it, depending on what your background is. But nonetheless, I had to, in a simulation, I had a partial script with sort of blanks, and I had chunks of code over here that I had to marry together and complete that script. And in other cases, I had a question where a penetration tester was supposedly looking around, doing their work, poking around on a machine, and they found this script, and I had to be able to analyze that script and come up with an answer. So the idea of what it would do, and that, since it might have been a clue for us to decrypt the encrypted data we were trying to get into, for example. And of course, another reason that I always say, even in the webinars we hold for this program, I've been asked, why is that programming class part of security? Because you need to understand the programming mindset, because you may have to help advise programmers on security practices. So if you understand the basics of programming, that helps there. You may have to help analyze software, and whether it's your own internally developed, and test it and recommend, maybe that needs to be secure, or there's a better way to do that. You didn't sanitize those inputs coming in from the user, so there's a risk there, whatever the case may be. A lot of the things you're going to face is a programmatic attack, those script kiddies and those bots, and even a custom written script by some higher end attacker who's trying to get you. So you might have to analyze malware or software after it's made it onto your network or onto one of your systems, whether that's all the way to reverse engineering, or at least being able to kind of poke around and see what it was doing, trying to understand what it was doing. And so it's important to understand programming in a number of ways, and that Pen Test Plus beta just reinforced to me that we're on the right track and we've made the right decisions to make this part of the program, because it is part of what, especially as you move up in the cybersecurity, you're going to need to learn more about. Many pen testers write custom scripts for the assignments that they're up against, and use some of the scripts in their library. And so the lesson starts off with a basic overview of just programming concepts. When you get down to it, every language has some rules, just like English has rules and Spanish has rules. Well, PowerShell has rules, and Bash, which is the shell scripting in Unix or Linux, or even Mac actually, because of that underlying Unix. Or if you get into the languages, like later when you learn Python and other languages, they all have rules, and those rules are basically the syntax, the rules of the language. So you need to learn those. And then they'll always have some keywords, certain words you can't use because you can't use them as a variable name. You can't use them unless you put them in quotes because they're just something you want to put on the screen or you want to store in a database. Sure, you can use that word, but you can't use them in your code because they're keywords. They mean things. And so then, of course, you have to understand the idea of variables. And so if you work your way through the lessons, we'll take you through. I'm kind of rambling off, and I can already tell you based on the fact that I'm not going to have a whole lot of time. We'll see if we do at the end. If I do, I'll show you a couple of examples beyond what are in the lesson. And if not, and any of you are interested, let me know. I can send you some sample scripts. There's some great ones out there if you just Google that, for that matter. But I do want you to understand that we show you the basics, and we show it in both languages. So we give you an introduction to programming, scripting, and then we show you a simple script in both PowerShell and Bash. And then your assignments for the exercise is to take that and extend it further, add some of that functionality like I was talking about, have it ask more questions and take more input. And you can actually, I would recommend you do it in both, actually. You're only required to do it in one. It says clearly, pick PowerShell or Bash, whatever you're more comfortable in, But I really encourage you to run through the exercise in both, because like I said, as you go forward in this program, beyond this program and beyond Security Plus certification, and start looking at the next steps toward the higher end security, advanced security practitioner, you're going to run into programming. And all 4 of those languages at least are on the beta of the CompTIA Pen Tester Plus. And I know many people have a natural tendency to be more on the pen testing side, the attack side, than the defense vulnerability management side of the cyber analyst. So I won't be surprised if more of our students would like to take that next test after the Security Plus to be the pen test one, but that's going to require some more programming, and definitely this program, and even some additional work that we'll have in the extension for later. But anyway, programming important, and we'll give you some more of it later. So then, that'll finish up the review. A little bit of dupe, maybe. I hope I didn't too much. But if we go into this week, we got our 6 lessons to talk about. And so lessons, or not 6 lessons, sorry, 5 lessons, but 6 through 10. Our lessons this week are, lesson 6 is on vulnerability and penetration testing. And like I said, and so this is actually a fairly high level. We want to present the concepts. And many people get confused and think that they're the same thing, and they're not actually. Vulnerability, they may incorporate one. The pen testing technically goes further, so it generally incorporates the vulnerability test. But I do want you to keep them in mind as 2 separate and distinct things. Vulnerability testing is all about testing your networks, your system, even your policies and procedures for vulnerabilities. We're looking for the gap. We're looking for so we want to use some software to potentially scan that server and see if there's any misconfigurations or ports that shouldn't be open or vulnerable systems or installs. We want to scan a machine to make sure there's no malware and things, no vulnerabilities, and same kind of deal. We want to scan our router and our firewall. We want to check things. We want to test things. Vulnerability assessment is to assess the vulnerabilities in our system. And a vulnerability can be something that, even though we're well aware of it, for example, we may have a network set up with firewalls and intrusion, everything we can imagine. And of course, we have a public web server, so that's operating somewhere on the real internet. Maybe it's in the militarized zone of our setup, but it's got to have a real IP for the most part. And maybe we could use NAT, but I mean, it's exposed, it's on the network. So we obviously have to let traffic to that IP, to that server, go through on port 80, or we can't make the web work at all. So if we have a web server, we have a vulnerable web server because it can be reached. We can't put up a firewall to stop it from being cut off. So it's vulnerable. We may have to do additional steps to make sure it's secure. So even if we know it's there, it's still something, it's a vulnerability, and we're going to rescan it and scan for it again and again every time we do a vulnerability assessment. We expect it to show up. Yes, we know it. But if anything else shows up, that might be a new piece. Or of course, it may be that the scanner then goes in and says, oh, now your database is out of date, or you need to update your libraries, or whatever the case may be, your Apache web server, if that's the piece that's needing to be updated. But the idea is that vulnerability assessments detect vulnerabilities, and that's where they stop. That's if you're tasked as a private individual, self-employed, this is the way you decide to go. You start your own security firm, and somebody comes and says, we want you to do a vulnerability assessment of our network, or our organization, or our campus, or our New Jersey facility. Then when you spec that all out, you're going to say, okay, I'm going to run these types of scans. I'm going to port scan. I'm going to run against your database. I'm going to run against this and that. I'm going to run these tools. And I'm going to stop and give you a report and say, this is what I found. You're running a web server and you've got port 80 open through your firewall. Well, yeah, we knew that. Thanks. But okay. But of course, if you tell them, when I found this was open and that seems to be back, what? They know about that. That's the point. But you didn't try as a vulnerability assessment, whether external or which happens a lot internally. People are run it internally, and maybe it's even automatic. We're going to run these like scripts, right? We're going to run these vulnerability assessments against certain segments of our network all the time to make sure nothing has popped up and we didn't know about, whether somebody added it accidentally, maliciously, or changed a rule, whatever. So vulnerability assessments just identify vulnerabilities, but we don't go any further. Penetration testing says, oh, I have vulnerabilities, which means by definition, either they were given the results of a vulnerability test to do their pen test, whether that's internal or once again, third party. And we even have a name for that. If it's a white box test, then they know everything about it. If it's a black box test, they don't know anything. So if we've hired a third party and not given them any information, they're just coming in blind. The reality is they're actually going to conduct their own vulnerability assessment against us first to then decide what is possibly something they could try to pen test and see if they can actually get in. And so, but of course, if they were hired or if it's internal, the vulnerability assessor, Bill, does the vulnerability assessment and gives Sue that report, and then Sue goes and tries to pen test and see if any of those known vulnerabilities are actually going to lead to privileged access to confidential data, lateral movements, gaining the shell prompt, whatever. But the vulnerability tester doesn't have to do that. So vulnerability testing is about defining vulnerabilities, and maybe even if, like in a third-party context, you might rank a report. We think these are, you better fix these. We know you got a web server, so we put that one down here low because it's not as important. And then the pen tester would either doing their own vulnerability assessment or taking that one and running with it would then attempt to try to actually exploit those vulnerabilities. And so that's the key difference. Vulnerability assessments only go up to a certain point. And even if a third party is hired in with no information, they're going to do two steps. They're going to run their scans and they're going to identify the vulnerabilities. And then they're going to look at those and go, okay, yeah, they've got 80 open, but they got a web server. I'll probably check it, of course, as a pen tester to see if I can get in. Can I do some SQL injection? Can I mess with it? Oh, okay, maybe not, because they know that one. But I'm going to look for other things. Oh, they got that old FTP server still on the network. Let me see if I can get in there. Or I'm going to social engineer my way in the back door as part of being a pen tester. And so we'll learn more about that. You'll learn more about all this as we go through the courses. But as your first exposure, those are the difference. And of course, we have all kinds of tools. We talk a little bit about the tools, and in the next course, this is system admin, right? Yeah. And network defense for you folks who progress this week and move on to network defense next week, and I hope a number of you do. You'll get to really dive into a really neat GNS3 topology, and you'll get to do. Actually, lesson 9 is all about doing vulnerability, and lesson 10 is all about pen testing, and we actually run numerous tools to conduct those types of tests. So then, if we look at the next few, I'm not going to quite merge them, but they're kind of together in a sense, because particularly 8 and 9, but 7 sets the stage for it. Secure protocols. Well, I can at least make this one fairly quick for us, though. As we already know, and should know at this point by now, there are a lot of protocols. We are using the underlying TCP/IP suite, and on top of that, we layer other things from FTP and email and HTTP and then all the web stuff we run on top of course, that. And funny enough, most people would define the internet today as the web because that's what they're used to dealing with. But of course, it's not. It's only one piece, one protocol of many, many protocols that can be used on the internet and over the TCP/IP suite. So when we talk about using secure protocols, what we're dealing with most of the time is making sure we use the secure versions of protocols, because TCP/IP is as it is in and of itself is not about security. IP is about addressing and making sure stuff gets from A to B. TCP/IP, the TCP part, the transmission control protocol part, is about making sure it gets there in the right order if it's needed. So we can send data over the internet using IP without TCP/IP. That's where UDP comes in. Useful when you want to just stream something out and you don't really care if it gets there in order or if the packet gets dropped along the way, because it doesn't really matter. There's a little glitch on the screen, and this is very likely using UDP. And so we're not checking every packet in order. But of course, if you're downloading a game that you're going to put on your computer, you really want packet 1 and packet 2 and packet 3 to be in that order when it's put back together. So when you run the installer, it doesn't fail, or the game doesn't fail on your machine. You want it to be faithful reproduction. So we use TCP/IP there, and whether we're downloading it off the web using HTTP or from an FTP site, we're using different protocols. So when we try to look at all the protocols that are out there, basically, the most important thing for us to do where we can is choose the secure version. So there is a move, even though there's some argument, I'm starting to even get more one over on this as we move forward, but there's been a push by Google and others that the web should just move to HTTPS. There is still some argument that there are lots of sites that, in my opinion, there's no reason for them to be HTTPS. Why do I have to encrypt when it's just Wikipedia, for example, or my menu off my restaurant site? But of course, somebody would say, well, then if somebody can see that, then they know they're looking at that restaurant. They know what they're looking up on Wikipedia. So I'm beginning to see, that more and more entities. And of course, it's being forced on us. Google and some of the other entities are going to even rank your search results if you're not using HTTPS. So we're going to see a movement toward more and more HTTPS with less HTTP. And that's basically the industry choosing the secure version of the protocol over. HTTP, HTTPS are identical when it comes to client server, give me a web page, give me graphics, stream my video, let me play my game. The only thing about the S part is that we've used public key, private key encryption, which you'll learn about in a class in a few weeks after network defense, to encrypt the communication. So when you like go to a bank or you go to Amazon and you get that little lock sign up in your browser, you know, it's secure and you know that person is that entity, you know you're talking to that website. It's all been validated, and it's all been validated by signatures and digital certificates and mathematics that do the cryptography. And then of course no one can decrypt that information, so they can't see what you're reading or what you're ordering on Amazon or what your bank balance is, etc. So, you know, in many cases it's all about choosing the secure protocol. So like, for example, for the most part, there are always exceptions, but for the most part, when we want to control, especially like all these new VMs and virtual machines up in the cloud that everybody's running in data centers around the world, and they're setting themselves, like I'm in Austin, somebody's in New York, and we're all managing stuff that's in a data center in New Jersey or Chicago or Seattle or all of the above, because we have virtual machines or we have our own data centers, or I'm working remotely on a client's machines, whatever. We're using, you know, like if I want to get a shell access, like you've seen using PuTTY in the Network Foundations class, I want to use SSH because, once again, I have to log in. It creates an encryption channel. Nobody can see. They can't see my password. They can't see my username if they're trying to sniff those packets, or some nosy busybody on the ISP upstream for me is trying to capture things. And so we would choose SSH over Telnet. And so, and then, you know, whenever we can, we would use the more secure protocol. But there's another aspect of secure protocols than just choosing the secure one. Obviously, if you can, that's great. That's what you want to start doing. We're going to move that way to the web. We've seen the movement. Like very, very, very rarely do you see Telnet, true Telnet being used anymore. Funny enough, one of the few places we see it is inside of GNS3. When you open up PuTTY and you connect to those virtual machines and the topologies, you're actually using just Telnet. Because why? Because they don't have to care. They know you're running it as a network. It's a simulation. It's right there on your machine, even though it's a virtual network in that VM. We don't need to have every VM inside of there have an open SSH and secure keys and all that stuff, right? We don't need that. And so you will see it in kind of lab and environments like that. But for the most part, in the wild, if you see Telnet anymore, it's very rare. And if you do run into it, and you will see it occasionally even in routers. It used to be common to Telnet into routers to configure them. And if everybody was secure, if you felt, you know, like your accesses were from inside your network and thus nobody could grab the data, then it was semi-secure back then. But of course, now theoretically, maybe somebody could, you know, have captured or put in some malware and they're capturing packets, and you definitely don't want any employees that running Wireshark and seeing you log into the router and then they have the keys to the farm. So once again, we moved from using Telnet to SSH, and even then to having maybe whitelist of IPs that only we can come in from those IPs. We can do all kinds of ways to secure these protocols. But occasionally you will literally run into a situation where maybe it's a legacy piece of equipment. This company's been around forever. They've still got this old piece of equipment, this old server, and this old setup, and this sort of little micro network back in the room because we need that database, and we have never migrated it. It's proprietary. It's out of business, but we need it. And it's still there. And the router that runs that little network is still the same one that came with it 10 years ago. And the only interface it has is a serial or telnet interface. Well, one, you don't want to open that up to the outside world. That's for sure. And so how do you secure that if you really still need to use Telnet? Well, once again, you have to do those other things. You have to you'd sandbox that area off, only allow in the traffic to the server as needed, and then you would let admins be able to come in. And you might even go so far as to force an internal VPN so that you basically are, say, connecting from your desk to that router in that little subnet, and then you use Telnet from there. And we know, because we built it, that there's nobody else, and that's all locked up in a closet, and there's nobody else but that old system and that old server and that old router on that setup. And so once we get to that by just VPN, which most people think of it like VPNing from home to work, but you can VPN from one segment to another, or one campus to another, or one part of the world to another, technically, however you want to set things up to route. So there, once again, there's most of the secure protocols is choose the secure protocol. But in some cases, when you do have to still use, or you're dependent upon an unsecure protocol for something, then you want to be able to think outside the box a little bit. And okay, well, I need to provide telnet access inside this to this thing. How do I do that? I'm not going to open that up through all our firewalls. Then telnet's wide open. People will be hacking, pounding on that, and et cetera. No. So we're going to keep that closed and locked down. And instead, we're going to let our admins know that they can VPN to a particular point here, and then use telnet from there, where there's no way that anybody could sniff at that point. And we have remote access, and we still are using telnet, right? So but you could use VPN to connect one office over the network to another. I've done that for clients before. They've got an office on this side of town, they buy one on the other side of town, and you can't run an Ethernet cable that long, and you don't want to buy dedicated lease lines from point A to point B in many cases from your teleco companies. So instead, they each have their own internet. We're going to use the public internet, but we're going to use virtual private networking to wrap that, so that that whole tunnel is created, a virtual private networking tunnel, and we can wrap it and thus keep whatever happens to go across that secure, because we've wrapped it in another layer. And so there's a number of things that are important about that. And we talk about all different kinds of protocols in there, not just the application protocols like HTTP, et cetera. We talk about routing protocols and other protocols, real streaming protocols, et cetera, et cetera. And so once again, if the protocol gives you, if you have a choice, then always use the latest version. Use the latest version of SNMP, Simple Network Management Protocol. Do not use the first one. Use the later one. It has encryption built in. It's just like, don't use Telnet, use SSH. Don't use HTTP, use HTTPS when you need to secure things. But if you do have to support an older protocol, then what you're going to want to do is, figure out another way to protect it. Protect it with firewall rules, set up a VPN, set up other types of mechanisms. So that's secure protocols. So then secure networks and systems, one of the things to keep in mind is we talk about, and there's some different kind of there's an interesting example in there of, and you could take that and run with it in the lesson 7 about how to set up sort of a standard network environment. But one of the things I want to come back to, we're only a few classes in, but here we are. Stuff comes back, right? When you think about developing a system could be one server, it could be an application, it could be a whole series of things. It could be a data center that's powering a whole process and multiple games and whatever the case is. Or you're just taking one network, or you're taking a campus network, or you're taking a global network. What are you trying to do? Well, first you got to define what you're trying to secure and what you're trying to design. But then really, I want to reference you back to some of the things in the very first class. Layered defenses in depth, right? Security by obscurity, maybe not. Diversity, okay. Remember, I told you you could use those concepts to both think strategically about the entire organization as well as tactically about a network or a particular system. So keep those in mind as you look through this lesson and think about network architecture. And we have some examples in there of setting up a secure network, kind of the standard model of we have an outside and an inside, and so we have a firewall, and then we expand on that so that we have multiple firewalls, and you could just keep building on that all the way into the exercises where we kind of do, and we ask you, I believe this is the right lesson that asks you this, what kind of devices you might continue to build on that to put into additional layers of protection. There are a number of best practices that I won't necessarily go through, but for secure system design. Unsurprisingly, some of them, once again, are like the best practices for just security in general, the best practices for securing a system or a network, or they need to be factored in while we're doing the design. We don't want to have open things. We want to use secure protocols. We just talked about that. We don't want to use default passwords, or in many cases, default settings, things like that. And so as we're designing, if we take all those concepts in the mind, and then we can balance, of course, that and the theory with the practical need of our organization, and ultimately it's budget, right? Because we all know we want to protect. Some companies spend a lot of money on multiple layers of routers, firewalls, and all this, and some companies throw up the router their ISP gives them, and they're up and running. And of course, there'll be plenty of big companies that spend lots of money and never get, they'll never get the breach, and then there'll be the small companies that never get breached. And then there'll be plenty who do both, and they will get breached. So it's not just a matter of spending money. There's holistics to it, right? And maybe they had thought through the great network design, but left a hole somewhere else. So we want to keep the whole thing in mind. But as we go in to design a new system, that's those practices and principles we talked about, you need to take in mind. But obviously, your organization has to look at you're going to look at your own security policy. How do you set up a similar system now? And then what things and why are you doing it that way? So that tells you what goals you're trying to achieve in the design of this new. Say it's a database. You're trying to replace one database system for another database. So you're going to design a new database system. That's hardware, that's software, that's the connections, that's everything. Well, what do we have now? What do we like and don't like? What is our policy to protect it? So what can we do when we design the new one? Well, one of the things that we have in our policy is always change the default password. So maybe when we design this one from scratch, we'll make the default password way better. So it's not just password, or maybe it's not a default. There's no such thing as a default. I've seen systems like that. There is no default. The first time it comes on, it's asked. So, things like it. So if we're designing and we want to take that problem away and make it more secure, but each organization, depending on the network or the system they're designing, will have to take into account all of our best practices, all of the principles we've learned so far, as well as their own unique needs, and then decide on what they're willing to spend. Budget-wise will drive some of that too. And so there's those trade-offs. When you get to lesson 9, as we head toward the end of the system administration class, lesson 9 is on secure deployment, and it actually is covered from 2 different areas, though for the most part they're really kind of the same. At the end of the day, when you put anything into your system, into your network, onto your your infrastructure, you have to have sort of thought that through. We don't want to just willy-nilly throw out new devices. Oh, look, the router was on sale. We got a different one. I knew we need a new office, so we got this one. What? We're going to have thought this through and follow public procedures and policies. And whenever any change is going to be deployed into our system, then it needs to be managed well. And there's a number of things to take in mind. And like I said, this can apply to just about any form of deployment. So are we deploying patches to the Windows operating system and Microsoft products? Are we deploying patches to our CCTV cameras? Are we deploying patches to our servers? Windows, Linux? Are we patching the OS? Are we patching the software like Apache and MySQL and on and on? What are we doing? So we don't want to do any of this willy-nilly. We want to have thought it through, and we want to come up with procedures for secure deployment. And what it really comes down to is when we put change into our network, we push risk potentially. Obviously, on one hand, it's a best practice to stay up to date, to patch and keep yourself up, because you need those security patches. That's a big part of what patches are, is fixing security problems. Now, they're also fixing bugs in their program and adding new features maybe, or fixing a feature that didn't quite work right. But especially, it seems, with the operating systems and major system services, that a lot of the patchwork is patching holes that are security holes. So we obviously on surface want those, but by the same token, it's fairly rare, thankfully, but it's not unheard of for a patch to break something else. The place I worked years ago, mentioned, I think, because of the VLAN stuff earlier, or maybe that was in the class. Never mind, that was the networking foundation class. So the place I worked before, we had Macs and PCs, and the Macs and the PCs all got along fine on our network. We could see each other. The Macs could see the Windows servers and Windows machines, and the Windows machines could see the Mac servers, and everybody was happy. And then Microsoft pushed out a update to the SMB, or Server Message Block Protocol, which is the base protocol that underlies basically Windows file sharing, as well as on Linux side, and for that matter now the modern Apple, Samba, or how it, and so they're all using SMB, but Microsoft updated theirs. And all of a sudden, none of our Windows machines could see any of the Mac stuff, and vice versa. Now, they were fixing a security bug, but it broke our whole network. It broke, and that was important because designers might be putting a proof onto a particular production server that a salesperson on a Mac, not on a Mac, but on a PC, could grab and then send, and now they can't. This is all broken. So, of course, we learned very rapidly that we needed to have some kind of secure deployment model. Now, God, I wish this was so many years ago, but I wish, and of course, it was not the modern versions of any of these OSs, but the point's still valid. I wish that we had had the virtualization tools at that organization like we do today, because it would have been much easier to test this. But we literally had an extra PC and an extra Mac that were set up just like our typical Mac and PC installations. And we had them set up to automatically update. And of course, we're aware, like, it's every Tuesday, Wednesday, depends on when your rollout happens for you, but basically patch Wednesday, patch Tuesday, patch Wednesday, when it boots, when you'll see it. But in the midweek, Microsoft will push out their patches. Apple pushes theirs out, different ones on different schedules. Android, iOS, everybody's patching and updating, right? So you become aware if you're managing these devices and supporting them. So we had these separate machines that really didn't get much use, sadly. Occasionally, we'd put a temp on them if we needed this extra person, because we always had these boxes. They were there for that very reason, our secure deployment model. And that was, our model was just this simple back then. And we deployed stuff to them first after that lesson learned, because we had to go back and spend the whole day and a half reverting all these PCs back, of course, and then turning off that patch so it wouldn't happen again, and good fun like that. And it's made much harder now with Windows 10s, limiting what you can stop from a patching point of view, though the enterprise does have more power than the personal and home versions and professional versions do. But that aside, the point is there that we want to manage our secure deployment, because we could, in our case, it broke our network. That wasn't a security issue. But in other cases, it might be a security issue. So you can follow my simple old example of, we would install these patches onto separate test machines, and then we would go out and test. Could they connect to the production servers? Could they connect to the Mac? Could they connect to the Windows? Could they connect to the font server? Everything works great. Then roll those things out, especially if they're critical security. Get them out to the rest of the network so we can plug the hole. But we didn't want to break our network. The same logic applies. You're using XYZ router or XYZ intrusion detection, and you get the notice, or your IT person says, hey, maybe a lot of times, sadly, the software outside of the operating systems themselves don't have a lot of automatic updates. So you may be responsible for monitoring a web page, or maybe if you're lucky from a really high-end vendor and on a mailing list, you might get a notification. Oh, we got a new patch coming out to fix these issues. And so once again, you do not just want to go and throw that patch on every one of your routers if there's a hole in it, because there's a problem, right? Maybe there is something that you don't know about, that patch causes a bug, and it causes certain types of firewall rules, UDP rules only, or whatever. I'm just making it up, but stuff like this happens. And so what you would do is, instead of like we did it to keep our stuff from breaking internally, not really a security reason, but there were elements of that in there. But in this case, if it was a router, we might have at least a little segment of our simulated network set up in GSN3, literally, whatever it is. If we have Cisco, we've imported those images in, so we have a Cisco emulation running in GSN3. We have the same kind of thing, our switches, whatever. And then when we hear that Cisco's got a patch, instead of running around that very second and putting it on every router, just trusting Cisco blindly, because we don't want to do that. And maybe for a small enough company, we can do it. It's not going to matter. You've got to make your own decisions. But in a big, really highly critical, highly regulated industry, then you're not just going to do that. You're not going to trust them at all, actually. You're going to take that patch and you're going to put it in that testing environment, and you're going to pound the hell out of it. You're going to run vulnerability scans against it. You're going to check to make sure all your firewall rules still work, that hasn't turned on or turned off your SSH and put telnet back on. Whatever it hasn't changed something that could be critical to your security. Then once it's past that kind of user acceptance testing, whether that's automatic or manual, and vulnerability and pen testers taking a look at it in a testing environment, and some of it can be automated in these days with the containers and different things that we can use to virtualize and spin up environments for testing. and run unit tests effectively and write scripts that'll automate some of those kind of things for us. Then we can run that through a battery of tests, and if it makes the check, then we can push that live. But then in addition, especially if you're a big enough organization where this matters, I'm a big fan of something else we talk about in the secure deployment chapter, which is called rolling out in stages. Because one of the things that I've seen happen in bigger organizations is that, okay, you do what we just described. You see there's a patch, and like I said, this applies to patching. This applies to you're going to change equipment. We're going to switch from Juniper to Cisco equipment. We better test that crap before we do it. So you better check it. So, and of course, it even applies, and it's more common these days. More and more companies build their own software. Whether they don't have to be a game company or sell an app, they may just give it away. Maybe it's the banking mobile app. Maybe it's just your website, but it's got functionality, and it's all built in-house. Well, you don't want to just make a bunch of changes, throw it up there, and then, oh, look, we left a SQL injection hole in the website. Bad us, says the development team, as the hackers were running through your network while stealing all your data. So instead, the same deal. You want to put it somewhere in a development testing environment, a staged approach, so that you can then test it. And then beyond that, when you really do decide to go live, if it's not just a one-off, then don't do it for everybody at once. Roll it out in stages. The idea being that, okay, and use some logic to this. And I've seen organizations do this. Okay, we're rolling out patches for all of the Windows machines. Actually, almost lost a contract at Dell for this because I went to do a demo one day when they were starting to roll things out. And they were rolling it out in stages, and they were doing it to the department that they thought would have the least impact first and during office hours, which was sadly the training department that I was trying to work with on a project years ago. So anyway, long story, if not for today in our limited time, but the idea was that they didn't just say, okay, it's been approved, we get our testing, the patch is good, and send it out to 10,000 computers in the same time. One, it's too much. They rolled out in stages just to limit the bandwidth and burden on their machines. They couldn't get it done all overnight when they tried. So, but what they learned to do though, even then, even with that testing, you've got a couple test boxes, or you got a bunch of test VMs, you got a rack of test machines, great. And you have 10,000 to roll it out onto. It's very possible that your test passed because it didn't quite run long enough, or because your test box didn't have Spotify on it that half your employees have on their machine. I'm just making up something, but the idea is that when you start to roll it out, you think it's gone through testing, but because then, unless that's an absolute replica of what you enforce on all your desktops, then the idea, maybe like I said, some of those things are like streaming. If you don't block them, it's not like they have to install anything. They can just do it through the web. But once again, that could be the condition of, well, this patch works great on all of our test machines, but it broke half of our computers when you pushed it live, you dummies in IT. How did that happen? And you find out, well, it had a conflict with Spotify, or had a conflict with something else, Java, whatever the case is, and then things break. And so if you have the ability to do it, and many times you may need to for efficiency anyway, you would use rolling out in stages. And then many times what you want to do is, yes, you want to do that, as sad as it is to say. It's like, okay, well, if we take down half of that department, what's going to be the least, who's the least impact in a short period of time? So who do we want to throw that to first? Accounting? Maybe not. Sales? Maybe not. I don't know. You definitely don't want to throw it to engineering, so anyway, so you can kind of decide. But I've seen people make different decisions on that. Some people roll out, it depends on how they got their network segmented. That's one thing. So it may be by building, so it doesn't necessarily affect job duty. It may, and then gives them a rod or sampling. That's one way to look at it. If all your accountants are similar with the exact same machines, and they're all friends in that department and run the same software, or even the same websites and extra third-party sites, then when it hits their machine, that rollout in stage may not trigger it until they get to XYZ department where there's a lot of people doing something else, and that's what really causes the problem. And I'm not saying that all patches or rollouts are problems, but they present an opportunity for a problem. And from a security point of view, we want to be very secure about how we deploy software. Well, patches and updates is one field. Software, whether that's third-party or in-house developed, or, of course, hardware. We want to be careful about that, and that's the whole point of that whole thing. And so you put those concepts into play when you're rolling out things, and generally speaking, you can avoid the worst case scenarios where you end up thinking, oh yeah, everything's great. We push this out and half the computers don't work anymore, and half your company's down, then that's a bad thing. And that's just on that side, because it may be worse. It may not be that it takes the whole system down, but it opens a hole that you didn't notice. And so in big organizations, that's the other reason, is because the rollout takes so long to do, and we don't want to, so we roll it out one night overnight. Maybe we're not going to be like Dell was that day that almost lost me that job, where I'm trying to do a demo and they're pushing patches in the morning to because it didn't get done, to the training group, figuring, it won't hurt them. It won't hurt us much if they're running slow. And it didn't hurt them, but it was making my demo look bad. But anyway, the idea being that, it may not be a break that's so obvious to see. It may be a hole that's opened up. And once again, it only didn't show on your test boxes, but it shows in combination with something else. That's the way computers work. Stuff overlaps and gets in, conflicts with each other, as we know. And it may work for your friend, but not work for you, your game. And the same thing, like on this hole may only open on certain systems. So if you roll it out to everybody, and then begin your follow-up to make sure everything was fine when you did the rollout, it may already have been found by somebody else. But if you roll it out to a small internal group first, or one office or one place, and then follow that with some additional vulnerability testing to make sure that additional holes weren't open. And that can be done with scanning of various tools, and it can be done by comparing against the baseline of what that organization looked like and what traffic ran through on its network before the patch and after the patch, or before the new software or before the new hardware. So these are important concepts to keep in mind. The last chapter, which given I have been running up to the wire, and I'm trying to get these done, so I have a few minutes between classes nowadays, but still running up to the wire. The last chapter is on the embedded and embedded and Internet of Things. And I won't talk a lot about that. That's fairly easy to read. The big thing I like to emphasize is that the Internet of Things is just a kind of catchphrase to today. It's like how cloud does admittedly reference, virtualization and big data centers, but virtualization and big data centers have been around before the cloud term came. And I've been using virtualization in my own network before that term was a big term. And so when you have Internet of Things, it's just really another modern name for embedded systems. And in the classic sense, embedded systems have been generally associated more with business and in manufacturing. So we're going to put some sensors and some computers and some oscillators and regulators and various tools that are basically on our network, and that brings our manufacturing line onto our network, so we can monitor as things go down, we can adjust speeds, and we can change things. And these control systems have been used to help, improve manufacturing processes and refining processes, and these types of embedded manufacturing controls are in just tens of thousands of plants all over the world. They've been very popular. And they were sort of the beginning of the idea of, if we can put a little bitty computer onto something and have it do something for us, in this case, run this machine, or make sure it doesn't overheat, or make sure this pipe doesn't get too much pressure, or if need be, if the pressure's too high, then adjust the mix. That's a control, that's an embedded system for manufacturing. And so when you think of a Nest thermostat, what in the hell is that? That's exactly what it is. It's a thermostat, looks like a thermostat, and it's a consumer product. So that's the difference between working on the manufacturing side. But it's a product, but inside of it, and it is a little computer with a network connection, like through Wi-Fi or potentially plugged in, and that's all it is. It's an embedded system, but its job is to manage your AC and maybe check for smoke and CO2 and things. I see too. They have all that built in, but it doesn't matter. We're seeing more and more of these. Your baby monitor or your camera on your webcam, these are when they're standalone, like little webcams, not tied to your laptop, of course, but standalone, D-Link cameras and wireless cameras, just refrigerators with a screen on the front that's a full Android tablet that can keep track of your shopping list and tell you when your milk's gone bad. That's an embedded system, but we call it the Internet of Things because basically we're going to put embedded systems into everything. We're going to put one in dog colors. We're going to put them probably on us. You may have it if you wear one of those fitness bracelets or a watch. You've got a mini computer right there that's doing heart rate monitoring and breath monitoring and step monitoring, and that's what it does. And so whereas our computers are general purpose systems that we can change by changing the software, embedded systems are a little more driven, even though I think that's going to blur when you can put a small, powerful, like you see with that tablet on the refrigerator or that kind of thing, where you're actually, in a sense, putting a full, more powerful device, and now it can run additional software. Heck, we're even seeing it. Alexis, the Echoes from Amazon, are little embedded systems. They have a computer and memory, and they, on top of that, they have the voice that, like Siri or OK Google, is being powered through the cloud through Amazon services. Not all that power of that voice is on that device. It has to go out to get that. But nonetheless, you can now create your own custom scripts, and other people are using that to build other stuff on. So we're going to see the embedded systems get more and more powerful. And so what are the implications? The implications is this stuff is coming on your network, and it's going to open up holes. I read a very interesting article the other day, which will be what I close this lecture on, but it talks about embedded systems. There was a casino in, I believe it was in Southeast Asia, but I can't remember exactly where it was, and it's not really relevant, I guess. The casino, though, was hacked. And their heavy hitters, their whales, their high roller list of customers was stolen. Now, that's a hugely valuable thing for a casino, because obviously it's like most things, like free-to-play games, supposedly 10% of the people spend 80% of the money. Well, the biggest high rollers that show up at various casinos, and especially if they're kind of loyal and they go to one, and they get the big suite and the private rooms and all the good service, because they go spend 200, they blow 200 grand or whatever, huge amount, 10 grand, 20 grand, whatever the limit is to be on their list. I don't show up at a casino and get treated like that, let's put it that way. So some of these people do. So a casino literally had their list of their top customers stolen from them. And when it was ultimately analyzed by the security firms, it turns out that they broke in through the fish tank. And that's the first I've ever heard of one like that. But literally, this very fancy aquarium that had been built into one of their entrances had some software and embedded systems in there to help manage the salinity of the water and the balance and to keep track of everything and automatically feed the fish. And it's plugged into the network. And that device was great. It took care of it, and the people managing it loved it. But then it was just like lots of this embedded systems, and these, actually even worse than the embedded systems, these Internet of Things. Most of these are consumer products, and the companies are trying to sell you a thermostat that's smart to get you into their system and to get you to buy it. Trying to sell you a refrigerator that's smart. They didn't say it was secure. They're not technology companies. They build refrigerators. Samsung may be an example that does a little bit of both, but I mean, a lot of the companies that weren't tech companies, they decided to go build a product and add this smart to it to differentiate themselves and make it cool. And it's the way of the future, but they're not securing them very well. So this fish tank became the foothold. They were able to get into this fish tank and the little system that was running it, and then use it inside the firewall to find their next weakness. And it became their entry in that allowed them to literally, and they literally transferred the file out that way. That's how it ultimately went down, through a fish tank. So if you never heard that story before, there's a new one for you. But that's the implication of embedded systems and the Internet of Things. Plus, you'll read some more neat examples and even scary examples of how we can affect those types of systems in the class. I'm out of time. I hope to see a bunch of you next week in Network Defense. If you have any questions, let us know on Slack. Thanks a lot.